When we use the term average, we usually refer to a particular type of average. There's three averages that are commonly used that you need to be familiar with: the mean, the median, and the mode. And in particular, the mean that we use is the arithmetic mean. There are other types of means like the geometric mean. The arithmetic mean really is what most people mean when they say average. When a student talks about their average for a particular course, it's the arithmetic mean, or their average for all their courses. So how do you calculate the mean? Well, the mean can be calculated by adding up all of the objects, finding the sum of the objects, and dividing it by the number of the objects or elements. So in this case, let's just add them all up. 16 plus 18 is 34, plus 21 is 55, plus 20 is 75, plus 16 is 91, plus 16 is 107, plus 19 is 126. And there are 7 objects here. So 126 over 7 gives us 18. So 18 is the arithmetic mean. Now, let me show you a slightly different way of doing this that I use even when I have a calculator handy, because it's often quicker. Sorry, the sum didn't move there. All you have to do, and this works particularly well when the numbers are closely grouped, it's a little less efficient when the numbers are spread out, is pick a number that looks close to the average. So you could look at those numbers and say, well, you know what, when I say average, the mean, I mean the mean looks to be around 18, but if you picked 19 or 20 or 16 or 17, it still works. I'll show it to you doing both. So let's say we picked 18. All right. All we do is we go along and we figure out the difference between the number and 18. So for instance, 16 is 2 lower, so I write a minus 2 there. 18, it's right on, so I write a 0 there. 21 is 3 more, so I write a plus 3, and then a plus 2, and then a minus 2, a minus 2, and a plus 1. And now all I have to do is add up those numbers in red, which is a lot easier, except for the fact that I'm dealing with some negatives, which might make it a tiny bit more complicated. Negative 2 plus 0 is negative 2, plus 3 is positive 1, plus 2 is positive 3, minus 2 is positive 1, minus 2 again is negative 1, and then plus 1 is 0. Now, if you happen to luck out and get a sum of 0 for that, it means you were bang on with your initial estimate, and the mean is indeed 18. But let's say you chose a different number, let's say 20 for instance. What do you do in that case? So I'll just scratch these out so they don't get confusing. So 20 you compare to all the numbers here. So we would write down a minus 4, a minus 2, a plus 1, a 0, a minus 4, a minus 4, and a minus 1. Now when you add those all up, what do you get? I'll just do the running count. Negative 4, negative 6, negative 5, still negative 5, negative 9, negative 13, negative 14. So we've got negative 14, and there are 7 objects. So when you divide negative 14 by 7, you get negative 2, which means that the real mean, the arithmetic mean, is just 2 below the one we estimated, 20, which again gives us 18. So this can be quite an efficient method. And if it doesn't work out to be an exact integer, that's fine. If it were, let's say, negative 10 as our running total over 7, that would just mean that the real mean was negative 10 over 7 away from our estimate. Okay, the other two are pretty straightforward, median and mode. Median just means the middle number in the set. However, the set must be ordered from least to greatest. So let's put this set in order. There is 16 is the lowest, and then we have another 16 and another 16. Sometimes it helps if you cross them off so that you don't repeat yourself. Then we have an 18, and we have a 19, a 20, and a 21. Okay, there are 7 of them. Which one's in the middle? 18. So here, the median is 18. Now, it's a coincidence that the median happens to be the same as the mean. That isn't all that unusual, but it's certainly no guarantee that the median will be the same as the mean. What do you do if there are an even number of objects? So for instance, let's say that we didn't have the 21 on the end there, and we only had those 6 elements. What do? You pick the 2 in the middle, which in this case would be the 16 and the 18, and you take the arithmetic mean of 16 and 18, which is 17. So in this case, with only the 6 elements, the median would be 17. Alright, the mode is perhaps the easiest of them all. The mode just means which element is the most common. And we have a 16 3 times in our list, and therefore the mode is 16. You can have more than one mode. If you have 2 modes, 2 elements that appear equally are equally common, then you would have a bimodal distribution. If every element in the set is different, then every single element is the mode. The mode really, I think, is the least useful and certainly the least common, but it does come up every once in a while.